We're looking at solving compound inequalities, and then I'm going to graph it. That may not be part of the assignment, but I'm going to graph it. And we're going to talk about the interval notation that corresponds to that. It's nice to have a picture, which is why I'm going to graph. Solving, I've got two different inequalities here, linear inequalities, and I'm going to solve them separately. So I'm going to do this fairly quickly. I can always do another example slower if you choose or if you want. So I'm going to do the inverse operation. We've got two operations. There's multiplication and subtraction. And I'm going to choose to do subtraction first, or deal with the subtraction first. The inverse operation, the opposite of subtracting, is adding. Do the same things to both sides of the inequality. -3 plus 3 is 0. I'm not going to write 0 because I'm lazy. And 3 plus 3 is 6. There we go. Now I have a choice here. I could deal with this as a fraction. It's times 3/4, so I could divide 3/4 to both sides. I'm not going to do that. I find it easier to deal with this as a times 3 and a divided by 4. Remember that a fraction is the same as division, 3 divided by 4. If I want to get rid of that divided by 4, the inverse operation, the opposite of divide, is to multiply. So I'm going to multiply both sides by 4. I'm going to get 3x, because 4 divided by 4 is 1, and 1 times 3 is just 3. 6 times 4 is 24. Now I can divide both sides by 3. And if you decided later or earlier that you wanted to deal with this as a fraction and just divide both sides by 3/4, if you're comfortable with that, awesome. You know, I've actually created extra steps here, but I find it easier for me to do if I just deal with this as two pieces, as a divided by 4 and as a times 3. If I deal with it that way, it's a lot faster for me. All right, so I've solved that inequality. X is less than or equal to 8. This is just scribbled. Next one here, I'm going to distribute because we have parentheses. You wouldn't have to distribute. You could do it a different way. I'm going to distribute though. So I've got 2/5 x plus, now again, this is like divided by 5. So I'm going to do 2 times 10, because I'm distributing, so I'm multiplying. 2 times 10 is 20. Divided by 5 is 4. And if I just threw you, you can check it in your calculator, you can write it all out, but if I'm multiplying 2/5 times 10, and I remember that a fraction is the same as division, 2 divided by 5, I can do 2 times 10 is 20, divided by 5 is 4. I just cleaned up my problem a little bit. Same idea as what I did right there, so I'm going to go a little bit faster. I'm going to subtract 4, because that's the inverse operation. For addition, I'm going to get -4. I'm going to multiply both sides by 5. I get that 2x is greater than or equal to -20. Divide by 2. I'm going to get that x is greater than or equal to -10. Whew, okay, there we go. So I have my inequalities solved. I've solved for x on those inequalities. However, I don't know how to write that in interval notation, and it can be helpful to have a visual. So I'm going to draw two graphs here. I'm going to draw one graph, I guess, here. This is my number line. Because there's only one variable, there's just x, I don't need to draw the y-axis because there's only one variable. This first inequality, it says that all the x's that are less than or equal to 8 are going to work in this inequality. So I want to find all the values of x that'll work here. So if I took 0, for example, 0 is less than or equal to 8. So 3/4 times 0 is 0. 0 minus 3 is -3. And -3 is less than or equal to 3. So 0 would work. Any number less than or equal to 8 will work in this original inequality. So I'm going to put 8 on my graph. I could put more. Maybe I'll put 0. I'm not going to put every number because, again, lazy. X is less than or equal to 8. So all the numbers on this side of 8 in my graph will work. 1, 2, 3, 4, 5, 6, 7, 7.5, 7.9, 7.9999999. You get the idea. And this has an equals to. It says x is less than or equal to 8. So in my graph, I'm going to put a closed-in circle. I know that's not part of the question, but we'll get there. Next, I'm going to graph this one a little bit faster now. So here's -10. All the numbers greater than or equal to -10 will work in this original inequality here. So for this inequality, I'm looking at all the numbers bigger than -10, including -10, or equal to -10. So really, any number less than 8 down to -infinity will work for this original inequality. Any number greater than -10 through infinity will work for this inequality. If it had to work for both at the same time, if this said and, x has to work for this inequality and x has to work for this inequality, I would say any number in between 8 and -10 would work. Because if it's less than -10, it doesn't work for this second inequality here. And if it was bigger than 8, it wouldn't work for the first inequality. But anything in between seems to work for both of them. Those lines overlap. Because it's an or problem, it has to work for this one or that one. Really, any number that's less than 8 will work. And any number greater than -10 will work. That's any number. Those lines don't have to overlap for the or. It just has to work for either one. So from -infinity all the way up to infinity, it'll work. And the reason I knew that is because of where these arrows go. These arrows keep on going down to -infinity, keep on going up to positive infinity. There's no break in between where it won't work. Every number will work. Now, -infinity and infinity are not numbers. It's just an idea. So even though these are or equal to, we're going to do parentheses because infinity is not a number. So it can't ever equal infinity. All right, one more quick one. Go a little faster this time. I'm going to solve this inequality. I'm going to solve this inequality. This was an or. There we go. And let's see, I'm going to add 1. 2x is less than 5. Divide by 2. I'm going to get that x could be less than 5/2, and that would work for this inequality. I'm going to add 3 here. I'm going to get -5x is greater than 0. And then I'm going to divide both sides by -5. 0 divided by -5 is 0. That's just 1. So I have 1x. When you divide by a negative, don't forget to flip that inequality around. I'm not going to prove it in this video because that would take too long for this video. But don't forget to flip that inequality when you divide by a negative. All right, so those are my two inequalities. Again, it's an or, so it has to work for at least one of them. It doesn't have to work for both, but it could. All right, x is less than 5/2. It's wonderful when you make your own graph because I can just make that line there 5/2. There's no scale. And 0. Okay, so for the first one, it has to be less than 5/2. Not quite equal to. Super close, but never quite equal to 5/2. Or less than 0. So really, I could draw another line. Maybe I will. Going that way. But you could almost draw it just right on top of it. And so we're going like that. You could draw either one. The key takeaway from this is, if I choose a number less than 0, say -1, I've also included this one. Because any number that's less than 0 will also work for this inequality here. This is an or compound inequality, so it has to work for either one, which means that even if there's a number bigger than 0, let's say 1. 1 is in here somewhere. There we go. 1 is in there somewhere. 1 works for this second or this first inequality. 1 is less than 5 halves. It doesn't have to be less than 0, but it has to be less than 5 halves because it's an OR. So any number less than 5 halves is going to work for both. So we'd only have to write that x is less than 5 halves. And that'll work for both of them. To write that with interval notation, I would say that I could go all the way down to negative infinity, all the way down to negative infinity, but I'm maxing out at 5 halves. I can't go above 5 halves and make it work for either one of these. Now, it's an open circle. It'll never quite equal 5 halves, so I'm going to do a parenthesis. Negative infinity is not a number, it's a concept, so it'll never equal negative infinity. I'm going to have a parenthesis there as well. If it did have an equal sign underneath, I would use a square bracket. Hopefully that helps. It can be, especially these compound ones, trying to figure out which of the inequalities do I use. Sometimes having a graph, even though it's not part of the assignment, is helpful, because then you can look at where those maximum points are, which direction the arrow is going, and kind of visually see where those numbers are. If you want another example, let me know, and I can maybe just draw one for you too, so you don't have to watch a video and listen to me yabber on.